Okay, for the next installment, we are going to look at multiple linear regression. Okay, remember the last topic, we looked at simple linear regression. For example, can we predict the weight from the waist? Or can we predict the weight from the hip? So you have, okay, let me just show it. What do I mean? Okay, by simple linear regression, okay, we are using one independent variable, such as the hip or waist, to predict or to construct or predict one dependent variable, okay, which in our case is the weight. So the next step is, can we combine these two into what we call as the multiple linear regression? So what does multiple linear regression do? Instead of using one dependent variables, what we are really trying to do is to use more than one dependent variables to predict one independent variables. So what we are trying to do is, can we actually predict the weight, construct equation for the weight equals to beta 1 of the waist size plus beta 2. Beta 1 and beta 2 is just coefficients, okay, of hip, and beta 0 is basically the y-intercept. Okay, so we are going to use identical equation here. So let's just use it. Now this is weight predicted by hip. Okay, if we want to add it on, we can just add on for the next one. So waist plus hip. Okay, so then do a summary, the model. There we have. Okay, so you realize that now there are three coefficients. Okay, and it is 75.747. Okay, remember when we use either one of them, our best result was 70.8%. Okay. So here it means that our equation, our regression equation, will be waist. This is 3.9. Okay. And hip minus the y-intercept. Okay, this is what it means. Okay. And the reliability of this model is about 75.5%, which is actually pretty good. So remember, the p-value here tells you that the Pearson's correlation, the R-square value, is significantly different from zero. And what does all these individual line means? It is actually testing individual coefficients. So it's asking, okay, now your y-intercept beta 0 is minus 80.2. Is it significantly different from 0? Yes, it is. It's lower than 2 times 10 to the power minus 6. Is the coefficient for the waist significantly different from 0? Yes, it is. Is the coefficient for the hip significantly different from 0? Yes, it is. Basically, it means that both hip and waist are important in the measurement. Okay. Another way that you can do it is, instead of using this plus symbol, you use the asterisk, which is times. It will produce another third coefficient. So let me show you. It will give you another third coefficient. which is the waist multiplied by the hip. Now you realize that this additional coefficient, it kind of pulls the value from the waist and the hip coefficient. So it's actually not that significant and it actually defeats the purpose as well. The R square value still remains the same. Okay. In fact, it drops a little bit. Okay. So this model is actually not going to be very useful. Although you still can use it, if you really want to have it, you will write the model in this way. Okay, the waist will be this coefficient, hip, okay, and the y-intercept, which is the given as an intercept. But we have the third component, which is plus the waist times hip. Okay, so waist times the hip. Now, why will this take place? Fundamentally, there is a fair bit of correlation between the waist, a person waist and hip ratio. Okay, so this is the basis of multiple linear regression. You can actually add on a lot more. The longest multiple linear regression that I have is thousands of variables. Okay, when I'm doing genetic studies. Okay, so that is how you interpret the R square, the R results for multiple linear regression. Okay, that's all for today. Have fun.